All right, today we will continue our study of experimental design, but now we're going to look at two new design models called block design and matched pairs design. All right, this is an example of block design. All right, when you know that there's going to be a significant difference between two groups when you're talking about some sort of experimental result. So instead of just mixing the two together and trying to get a random mix of, say, men and women, for example, sometimes you can get more information if you bring that difference right into the experiment by separating your subjects into two separate groups and basically running the experiment twice. When you separate like this and run the experiment twice, the separation is called blocking. So you would make one block of men, for example, and then run your experiment, randomly separate your men into groups, randomly assign the therapies to those groups, and then compare how your treatments affected the men, and then do the same thing with the women and see how your treatment affected the women's results. Okay, you wouldn't really compare so much the results of the men versus the women because you already know they're going to be different anyway. But just comparing the men and comparing the women will give you a lot of information. And that can be true with age, weight, sometimes race. You'd want to separate out whites, Hispanics, Asians, Caucasians, if you know there's going to be a difference. So this is a block experimental design. On the other hand, matched pairs design is when each subject has both treatments, and the only thing that changes is the order in which they receive the treatments. For example, all right, if a researcher wanted to find out which would cause a sleepy subject to become more alert, coffee or Mountain Dew. If you're going to do a matched pair experiment, then each subject would wind up having both coffee and Mountain Dew, not at the same time. But for example, one subject would have coffee and then see how the coffee affected their alertness, maybe by doing some task that requires alertness that you could measure. But then later, maybe the next day or something like that, after enough time had gone by, then that same subject, under the same conditions, would now have a Mountain Dew instead. So they had coffee and see how that affected their alertness. And then another time, they would have the Mountain Dew. And then you would compare how alert they were under the coffee versus how alert they were after having the Mountain Dew. Okay, that's matched pairs. But the thing is, some subjects would have the coffee first and then the Mountain Dew, and other subjects would have the Mountain Dew first and then the coffee. And that would be your different groups, would just be the order in which you do it. But you would never really compare the two groups. You would just be comparing the results of the two treatments. Anyway, let's get started. All right, problem number 1. Does talking on a hands-free cell phone distract drivers? Undergraduate students drove in a high-fidelity driving simulator. That means like a high-definition, realistic driving simulator equipped with a hands-free cell phone. The car ahead brakes. How quickly does the subject respond? 20 students were involved in this matched pairs experiment. Design the matched pair design appropriate for this information. Now, understand, based on what I described before, if it's a matched pair situation, then each student, each subject is going to actually experience both treatments. So in this context, we've got the hands-free cell phone is one treatment, and then not having a hands-free cell phone will be the other treatment. Okay, that will be the control. So in this case, each subject will experience having a hands-free cell phone and see how fast they react, and they will also experience driving without a hands-free cell phone and see how fast they react. So watch how we set up this design. Okay, we start off with all of our subjects. So we start off with 20 students. Now, these students have to be randomly assigned into two groups. Alright, so the idea is these 20 students will be split up into two groups, which we could call Group 1 and Group 2, each with 10 students. Now, as far as the diagram goes, we need to mention how the students are being separated into these groups. The fact is that they are going to be randomly assigned. But what I'm going to do is I'm going to put an extra little box in here mentioning random assignment, and that's going to be very important. Alright, so be careful not to leave this out. Now this random assignment block is going to appear twice. In almost every design we do, you're going to see this random assignment twice. Once when you're assigning subjects into groups, and then again when you're assigning groups to treatments. Okay, so always look for the random assignment to show up twice. Okay, so here we go. So now we've got Group 1 and Group 2. Now, now each group is going to receive both treatments though, because this is a matched pairs experiment. The only thing that's going to change is the order. So the two treatments are hands-free cell phone and no hands-free cell phone. Alright, so this is the idea right here. For example, maybe Group 1 has the maybe Group 1 first tries their luck with a hands-free cell phone, and then they run the simulation again without the cell phone, and then they compare those results. While Group 2 does it first with no cell phone and then with the cell phone. Okay, the only thing that's missing here is, again, we need to mention how the groups are assigned the order. Alright, whether Group 1 does a cell phone and then no cell phone, or do they go no cell phone and then cell phone. And again, that's going to be random assignment. So I'm just going to shift all this over and put that extra block in there to show that it's the treatments are randomly assigned. Alright, see there, I've worked that in there. So now the groups are then randomly assigned the two different treatment orders. So we have to get that in there. I haven't left myself enough room over here to put the block about where we talk about comparing, so I'm going to have to go back and squeeze that in. Alright, well, I'm really running out of space here, but I squeezed it in. Compare same subject response time, phone versus no phone. Alright, so it's really tough for me to fit this all in here, but this is your basic design of a matched pairs experiment. Alright, let's do problem number 2. Bee pollen is effective for combating fatigue, depression, cancer, and colon disorders. At least that's what it says on the website that offers the pollen for sale. Now we wonder if bee pollen really does prevent colon disorders. So here are two ways to study this question. The first way is to find 400 women who do not have colon disorders. Assign 200 of them to take bee pollen capsules and the other 200 to take placebo capsules that are identical in appearance, and follow both groups for 5 years, and we would compare. By the way, we would definitely randomly assign the women to these two different groups. Anyway, that's one way to do it. Another way is to find 200 women who happen to already be taking bee pollen regularly, and then match them up with 200 women, match each one up with a woman that has the same age, race, and occupation, who doesn't take bee pollen, and then see how they compare over a 5-year period. Which design is going to be more trustworthy? Look, the first method is going to be more trustworthy, all right? Because, all right, we want the two groups, the experimental group and the control group, to be as similar as possible. Now, by randomly assigning the women to the two groups, you're going to get a statistically homogeneous mix. Okay. Now they won't naturally be all the same age or the same race or anything like that, but the groups as a whole will be the same. Now, even though you tried very carefully to match each woman with a woman of the same age and same race and occupation, all right, so you've controlled for those 3 specific variables. There are 1,000 variables out there that you are not specifically controlling for. Now, the thing is, you might not think of it right now. So here are a few variables that popped into your head. But accidentally, by grouping together 200 women who already take the bee pollen regularly, you might not know it, but the thing is, women who happen to take bee pollen on a regular basis, that's something that they already have in common. They might have other things in common that are going to affect the outcomes of the study. All right? I mean, how many people do you know that take bee pollen? Okay, not very many. Now, if you put together a bunch of these unusual women who happen to be taking bee pollen, these might all be women who, if they're taking bee pollen, which is not a really common thing for people to be taking, they might be taking other things that are uncommon, other herbs and non-traditional treatments that they might be doing. They might be eating other foods that are unusual. They might be vegan, they might be vegetarian. If they're doing the bee pollen, then they might have other things in common. They might be all about the Mother Earth and holistic healing and alternative medicines. So by grouping them all together, you're inviting some lurking variables that you can't even think of off the top of your head. Who knows? But if they have this one major thing in common, bee pollen, the fact is there's a good chance that they have a bunch of other things in common that we're not really intending to accidentally study. And those would be your lurking variables. Okay, so that's why the first method avoids just having a whole group with something huge in common right off the bat before we even got started with the study. And so that will avoid some of those lurking variables. All right, here, I'm going to leave this on the screen for like 10 seconds for you to read through. This is my write-up of what I just said. All right, let's move on to number 3. All right, problem number 3. Actually, I don't like problem number 3. I read over the problem and it's very vague and it really doesn't make sense for this to be block design anyway. So, bottom line, forget about problem number 3. Just skip it. Putting a big X through it. I don't like it. No me gusta. Let's move on. Alright, let's go on to problem number 4. Nurse practitioners are nurses with advanced qualifications who often act much like primary care physicians. An experiment assigned 1,316 patients who had no regular source of medical care to either a doctor or a nurse practitioner. All of these patients had been diagnosed with asthma, diabetes, or high blood pressure before being assigned. The response variables included measure of patients' health and their satisfaction with their medical care after 6 months. Is the diagnosis, asthma, etc., a treatment variable or a block? Why? Well, given those two choices, asthma is definitely not a treatment. They definitely are not going, oh, let's try out asthma, see how that works. Yeah, how you feeling with that asthma? No, that is something else. It's a pre-existing condition that you might use as a blocking variable. Okay, so you could run the experiment on all the people who have asthma, and then you could run the experiment on everyone that has diabetes, and then all the high blood pressure people. So definitely a blocking variable. Alright, on the other hand, the type of care, the nurse or versus the doctor, is that a treatment variable or a block? Well, that's clearly the treatment variable. A block is some sort of a pre-existing characteristic of the subjects. Whether or not the subject gets a nurse or a doctor, that's an experimental condition, so that makes it a treatment. Okay, how about number 5? You are participating in the design of a medical experiment to investigate whether a calcium supplement in the diet will reduce the blood pressure of middle-aged men. Preliminary work suggests that calcium may be effective and that the effect may be greater for black men than for white men. Outline a block design for this experiment. So, since they've already noticed that the effects may be different for black men versus white men, then it would make sense to create a block for black men and a block for white men, and run the experiment separately as a block experiment. Okay, so we'll start off with the two blocks, black men, white men. Alright, begin with the blocks. Alright, to help remove some of the lurking variables and improve the reliability of our results, we always want to randomly assign our subjects to their groups. So let's put random assignment next. Now we're randomly assigning to their groups. So, okay, so here the black men are randomly assigned to either group 1 or group 2, and here the white men are randomly assigned to group 1 or group 2. Alright, next it's time to assign the treatments, but once again these treatments need to be assigned to each group randomly. So we need another random assignment characteristic here. So notice how the random assignment happens twice. I'm going to be looking for this in your designs. I should see random assignment assigning subjects to their groups, and I should see random assignment assigning groups to their treatments. Alright, so that should show up twice. And then finally there's the comparison. Now when you mention this sort of closing remark about comparison, be real specific. Don't just say compare. You need to mention the response variables that we were looking for in the description of the experiment. So let's scan through and see what this was all about. We're looking to see whether a calcium supplement will reduce the blood pressure of middle-aged men. Okay, so we're going to be measuring blood pressure. So we're going to be comparing blood pressure between these two treatments. So that's what you're going to say. Compare blood pressure. And there you go. That would be the design for a block study for this situation. And I'm just going to leave this on the screen for a second so you can really absorb it, but make sure that you can set this up on your own. Alright, I get that you might be sort of copying right now, but obviously if you're copying you don't really know it yet, you haven't internalized it, so you're going to want to come back to this in a little while and see if you can come up with this design on your own without copying.